Hello and welcome again. In this video, I will show you how to perform the ventilation analysis using the XIPline application. To start, please select the sequence type. Here, for the Xenon Consortium protocol, we're going to use the 2D GRE for ventilation images. You can specify scanner type or scanner software if you customize the application to your data. Then we will go to image type, uh, um, the image analysis tab, and then we will select the ventilation analysis from the drop down here. Next, we will select the Xenon images. Just navigate to your Xenon ventilation images and then select the DICOM. If you have multiple DICOM or a single DICOM, just select the first one. And the application will read all the DICOM images in that folder automatically. You can also choose to do denoising images based on the BM3D method. However, for the interest of time, we will skip this step. If you don't have proton images, then select this option. But if you do have anatomical images, then select the anatomical images as well. Again, just select the first DICOM image. Lastly here, there's an option to perform the analysis all steps at once. However, I do not recommend this one if you're performing the analysis for the first time, but if you're familiar with the application after some time, then you can choose to perform all the steps together. However, we will do step by step in this demo. Once you select both the Xenon and the anatomical images, and then we will load the images. Here we have the anatomical images shown here, and then you can scroll through the images or the slices. Then you can also view the ventilation images by selecting the ventilation from the drop down here, and then view. Again, you can go through the slices. As you can see here, there are a few tools that you can use to manipulate the images or view the images as you see fit. I'm going to go through them really fast just for you to be familiar with. For example, here the crosshair, this is just to turn on and off the cross. You can change the color. You can change the thickness. And then you can change the size of this window. I'll leave it to this default. You can also change the color map to view the images in different color maps. And then you can also do rotation and flipping. This is the degree of the flipping or rotation, so specify the degree here and then click rotate or flip. For example, if I want to flip, for example, here, I will flip this one here. This one flipping top, bottom, and then I'm going to flip it back. If you do the flipping and rotation, or even swap dimensions, choose the dimension that you want to swap, the first one with the second one, or the first one with the third one, and so on. You can also play with the contrast of the images to view the images. And then you can reset the contrast. You can also, if you want to look at the value of each pixel, you can click on this option, Pixel Info. Will show you only the information in this slice. So for example, here, you can see here, I have a few tools here. I have a window that I can drag. And then I also have a line that I can use to measure the distance in pixels, of course. I can even zoom in to see the value in each pixel. Just something useful you can play with. And then you also have the MSlice viewer. This one will view the image in 3D. So once you get this window, then drop down, select 3 dimension, and then you can also view the images as shown here. This is very helpful when it comes to the 4 dimension, the diffusion images, that you can view the p-value and the slices all together in this application. If you did any manipulation like rotation, flipping, swap dimension, and you want to keep the changes, all you have to do is apply changes here. But if you don't have to, then you don't have to do that. If you did anything and you want to in the settings and you want to go back to the default setting, then you have just to click on reset, and it will reset the these options back to the default settings. And of course, you can do all same manipulation to the proton images as well. All right, so now we have our xenon and proton images loaded. Then we will move on to the second step, which is the registration. You can choose the transform type. However, I'm going to leave it to the default affine registration. And then for the image resolution, usually go with use the ratio. We'll use the ratio between the xenon and the proton images. It is basic registration. It's not a very sophisticated one. So if you don't get a good result, and click this option and play with these the size of the pixels to get a good result. I'm going to leave it to the default. The slice selection here, this is very useful if you have the number of slices is different between xenon and proton. So you can select the xenon images that you want to keep from which slice to which slice, and then the same thing for the proton images, the beginning slice and the end slice. They don't have to match the numbers. This is the whole point. So for example, here if you start from 1 to 14, here you can start from 5 to 10, and then we will do interpolation to match the images. The key point is that the anatomical position between the xenon and proton from the beginning needs to match, and also at the end. But we will leave it and clicked for now, and then we will perform the registration. All right, here is the result for the registration. Again, you can scroll through it, and if you're happy with it, that's good. If not, then click this one and play with these the size of pixels until you get a good registration. All right, move on to the segmentation. The segmentation, we have 3 different methods to segment the long parenchyma. We have the manual option, the threshold, and then the auto segmentation. And of course, if you already have an existing mask, you can load it in 2 formats, either .mat file, MATLAB file, or an FTA file. Those are only 2 data format the application supports when it comes to loading an existing mask. I'm going to go over these 3 really quickly. For the manual one, choose manual here, and then which kind of image do you want to segment? Do you want to segment both these registered? So you can use the proton images as a reference when you draw the mask, or you can use only the xenon image. And of course, you can use the registered proton image. For now, I'm going to use only the xenon image. And then second, select the anatomical either parenchyma or airway that you want to segment, and then you want to use which kind of method, manual method. Here we will use the freehand since I am using the compiled application. However, if you are using the application in the developer mode, which I will mention later, that you can use the app segmenter, which is very useful application developed by MATLAB to do all kind of segmentation, and it's very useful application. However, it is not supported when it comes to compiled application, so we will use the freehand for now. Once you select these two options, then we will start the segmentation. This is obviously the first slice, which is just noise, so we're going to skip it to the next slice. Again, same thing. This is the beginning, so you can add segmentation by clicking on Add. And then all you have to do is choose any point, use your left click the mouse and keep dragging. Obviously, I'm not doing a great job, but this is just a demo. And then, of course, you have to keep adding. Once you have a decent mask, move on to the second slice. And then again, add segmentation. One thing I have to mention, if you do this manually by hand, you have to be an expert when it comes to the longer parenchyma, boundaries, and especially when it comes to sick patients when you have lots of defects. So could be the half or the entire lobe is gone. So you have to know a little bit about the long anatomy to be able to perform the segmentation accurately. You can also edit the mask. For example, if you did a mistake like this, for example, and you want to remove that part, and then choose remove from here, and then select the part that you want to remove. Okay. You can also go back slice if you feel like you missed something and you want to edit the previous slice. Then you have just to click on go back here and it will go back to the previous slice, or you can keep going to the second slice. I think you get the idea. I'm gonna skip this one, but once you finish this one, doing part by part until you finish the entire log. Once you finish this one, you have the lower mask here, which you can view. Then when you just segment it, so we skipped a lot of them. So we only did the first two, this one and this one, and then nothing else left. Okay, so next I'm going to move to the second method, which is the threshold. The threshold, again, just choose the anatomical part. So we're going to choose the parenchyma. This is the threshold level, and then the erosion level, and you kind of experiment with these things. For example, here I'm going to use the one for now, and I will show you how is the result. So all you have to do is do that. Okay. Obviously, you can see here it did a decent job, but it's still missing, for example, here part of the lungs here. And of course, you can edit that by clicking on Edit Mask here. And again, you can scroll through the slices. For example, here needs some filling, so you can do add segmentation here. Move on. Move on. Like for example, here it's missing, so we can add this one here. And so on. So you can see here, it filled it nicely. And of course, you can do the airway as well by clicking on airway. However, when you do airway and threshold, it does not really work. So you have to do the airway manually. So if we click on, even if you select threshold, it will default it to the manual one. So scroll through the slices again and trying to find the airways. Obviously, there's no obvious airway, so I'm just going to skip it for this example. And then the last one is the auto segmentation. If you remember how we set up the folder and the machine learning models, and so we will be using those models to perform the segmentation. All you have to do is select auto here and select xenon here, and then choose the slice orientation. Here we have corner slices, so we just choose corner slices and that's it. And then perform the segmentation. This obviously will take a few seconds because it will be calling the Python scripts and then perform the segmentation and then load it back into the application. So all you have to do is just wait. All right. You can see how here we have much cleaner mask compared to the threshold. Very nice. And of course, you can edit the mask same way we did for the threshold. But if you're happy with the mask, that's good. And we can move to the last step, which is performing the analysis. Here, you can also apply bias field correction. And then you can choose the type of VDP analysis. So I'm going to choose the threshold, the 60% method. And then you can also adjust even the threshold by itself, but the default one here is 60%. And then also you can do linear binning. And then if you choose the bias field, you have to edit the mean and the standard deviation of the healthy distribution. Here is the default values. However, it might vary depend on the acquisition type and the scanner type. So you might have to be careful with these numbers. But for now, those are the default values. If you don't click the bias field, then you have to edit those two. But for now, we will perform the bias field, and then we'll leave this one as the default. We can also perform the k-means VDP. We can also perform the defect distribution index, the 2D and the 3D. So if you choose the 2D, you have to choose what kind of, because the input for the DDI analysis is the VDP mask generated by one of these methods. So you have to choose one of these methods. So I'm going to leave it to the threshold method. And you can, of course, perform both of them, the 2D DDI and the 3D DDI. However, if you do the 3D DDI, you need to provide the voxels and the slice thickness because it will interpolate it into a 3D volume and we will need this information. However, for the interest of time, I will keep the DDI out for now. And then lastly, we can also perform the texture, basic texture analysis that I will show you when we get the result. All right, once you select all of those, all you have to do is perform the analysis. This will take a few seconds because it will calculate the SNR and then it will start popping out, as you can see here.
Ventilation analysis completed.
Once you have the analysis completed, then you can go to the result tab here and you can view the results. So you can see here the VDP 1.4 for the threshold method, for the linear binning 3%, for KME is almost 1%, and so on. You can of course view the map. For example, here if you click on the VDP map, you can scroll through the slices and see the defect maps. You can also look at the histogram. You can look also at the linear binning analysis. And of course, you can look at the histogram as well. And then you can look at the k-means VDP map. And then here we have the texture analysis using the GLRLM method. There are the, I think, 12 parameters that you get, the short emphasis, long emphasis, and so on. And this is just the mean value across all the images. All right, once you have the ventilation analysis completed, this is the last step is an optional step, which is creating a report. So once you have the analysis completed, you can start by filling this, the study ID, for example, here IRC001, for example, study type, for example, we say CF, patient ID is 001, the scan date, for example, here, and then the xenon dose volume, say 1 liter, patient name, arm number, and then if it's the gender, and then the age, height, weight, similar finding, say low VDP. You can add additional notes. You can add your initial, the person who performed the analysis, and of course, today's date or the date when you perform the analysis. Once you do that, you can generate report. This will create a PDF of the PowerPoint, which I will show you in a second. Once you get the green light here, you can navigate to the data folder, and you can see here you get a ventilation analysis folder here. Open it. You will have a PowerPoint as shown here. Show you the report that we filled, and then a few slices and of course the VDP, the PDF file that we generated here. And then you get inside the VDP analysis all the TIFF images, MATLAB images, um, histograms, and then under the texture analysis, you get also the Excel file, which is showing the mean, and then the mat.mat file. And that's it for the ventilation analysis. Thank you.